Evan Fry, and I'm a biochemistry and economics sophomore from Milwaukee, Wisconsin.
I'm Zach Mason, a finance and accounting senior from Utah, Oklahoma.
My name is Nikki Bray. I'm an aviation and environmental science junior from Oklahoma.
I'm Andy Atkin. I'm a political science and business management major from Louisville, Kentucky. Our team leader is Jake Kumar. Our mentor is Dr. Phoebe Kalobi, and our mentor is Daniel Pullen. And collectively, we are the Sippc team. There are 4.1 million children born in the United States each and every year. For each of those children, their parents, family, friends, and loved ones look forward to their firsts. The first time they laugh, the first time they smile, the first time they learn how to crawl or take that first step. Their parents and loved ones are there for each and every one of those moments. For children with developmental disorders, that's not their reality. Those firsts are delayed. Those parents and loved ones are concerned about their children as they move forward through those steps. For those children, they face problems with motor control due to brain damage that can occur during gestation or immediately after birth. That is the reality for 17,000 children born in the United States each and every year, for 17,000 families here in the United States every year. There are 2,000 infants born with spina bifida, 5,000 infants born with Down syndrome, and 10,000 infants born with cerebral palsy every year. For those children, they face physical challenges that include coordination of their limbs, a head and body that are too heavy for them to lift off the ground, mental challenges including disuse of their neural pathways, and delayed cognitive development. And those two problems combine to create learned helplessness. Learned helplessness essentially means that when a child reaches out with their left hand and they're not able to move across the floor, when they reach out to grasp something and they're not able to do so, they just stop trying. This is the challenge that children with cerebral palsy and other developmental disorders face. The solution, then, is to address all of those problems. Physical challenges can be addressed by allowing limb movement, supporting their head, lifting their body off the ground, allowing them to use their neural pathways, encouraging cognitive development, and providing positive reinforcement so when they do try and reach out to learn how to crawl, that they're able to do so, that they don't just stop trying. The self-initiated prone progression crawler is that solution. This assists infants in learning how to crawl by raising their body off the ground, providing support for their head, and allowing unimpeded limb movement. As you can see in this picture, we have 4 methods of data collection. First and foremost, the wheels, which track the acceleration and distance moved across the floor. Secondly, we have load cells, which track where the baby is on the board. If the child shifts their weight to the left, the board can detect that and assist them in trying to move across the floor. We have accelerometers, which are attached to the various limbs of the child. So if the child reaches out with one arm and they're attempting to move in a specific direction, we can detect that and assist them in that movement. In the future, we look forward to electroencephalography nets, which will track the electrical impulses in the children's brains so that we can detect the neural activity that is occurring in their brain, not only as they use the Sippc, but before and after, so that we're able to completely document their progress through use of the Sippc. These 4 methods of data collection provide positive reinforcement to these infants. Again, that is the most important thing that the Sippc can do. The Sippc teaches these children how to crawl, but most of all, it allows them to continue trying, to not just give up. Nikki is here to explain how the Sippc is different from other products.
All right, so what makes a Sippc so special? First off, Sippc is backed by extensive research. Research has been conducted by Dr. Kalobi and her counterpart, Dr. Peter Pitko, from Virginia Commonwealth University, over the past 4 years. Secondly, Sippc is a patent-pending product. That means that the intellectual property behind this technology is secure, or will be secure once it's approved. And finally, Sippc is a proactive solution. This is important because most children who are diagnosed with cerebral palsy don't begin their treatment until after they've passed a developmental milestone, such as learning to crawl or learning to walk. However, with Sippc, a child who is known to have CP can begin their treatment as soon as they're diagnosed, therefore shortening the window where the neural pathways in the brain begin to close down. Let's see how Sippc stacks up against the competition. First off, we've defined 5 metrics that will analyze our competition. First, we have physical and mental stimulation, 2 key factors that Sippc and other products provide to children who have CP. Physical stimulation indicates that children are receiving stimulants to their muscles through the act of crawling or being worked with through therapy. Mental stimulation is what a child receives from exploring his or her environment, fostering cognitive development. And finally, Cost to family, which is important because children with cerebral palsy and their families often have to endure many costs when they're dealing with it. Early therapy is a metric that defines how early a child can begin treatment in his or her life. Measurable outcomes is defined as how much evidence supports the device's effectiveness with the child. For many children with cerebral palsy, physical therapy is the first and the most common form of treatment. Physical therapists working with infants often work with them on their laps, moving their limbs in such a manner that will stimulate crawling. For most infants, this is great, but it doesn't give them the mental stimulation that they need to foster cognitive development. Also, it's difficult to measure the effectiveness of physical therapy one-on-one in an objective manner. Our next competitor we see are typical crawlers. A crawler for a child with cerebral palsy is not unlike something you'd see as a scooter you'd see in elementary school. Crawlers are devices that assist a child in crawling in their early age. However, crawler is limited in that a child must be large enough and have enough muscle mass to use a crawler on his or her own ability, or with the assistance of someone helping them. It's also difficult to measure the outcomes of a crawler objectively. The next competition is from the University of Delaware, where they developed a mobility trainer. The mobility trainer is actually a robotic crawler, and it's targeted at children who have moderate to severe cerebral palsy. The mobility trainer lifts the children off the ground, allowing them to navigate around, giving them positive mental stimulation. However, the child's body is not actually making contact with the ground or crawling under his own power, therefore they're not receiving the mental stimulation necessary to develop their muscles. Using accelerometers and a joystick, the child's movements are tracked, and then the crawler moves about. However, this technology is costly because it's under new development. Also, it's difficult to measure the outcomes because it's not backed by the same research as the Sippc. Finally, we have Sippc. Sippc means the physical and mental stimulation necessary to help a child with cerebral palsy become more active and get back on the learning curve with their able-bodied peers. However, it is a higher cost technology because it's very new. But most importantly, it does offer an early therapy option for a child, which allows them to shorten the window of their developmental disability. And it is backed by measurable outcomes. As you can see, Sippc stacks up against the competition. It's got the most going for it, except for the cost. So let's see what kind of markets are available for the Sippc. The first market we're looking at is physical therapists. Physical therapists who work with children both in the clinic and outside the home, in the home. The second market is the parents of children with disabilities. This market will be targeting parents so they can take the Sippc home to their children and work with them on their own time. And finally, the third market is targeting parents of able-bodied children as well as parents of children with developmental disabilities. This market is a very different version of Sippc. It's much more simplified, and it's targeted to help those parents of children who want their kids going and crawling as soon as possible. These are the potential sizes of markets based on the financials available. In market one, we see that there are about 5,000 pediatric physical therapists in the United States. For these therapists, 95% of their caseload deals with children who have developmental disabilities. That number multiplied by a price point of $1,500 per device gives us $7.5 million potential in the first market. In the second market, we see there are 17,000 children born annually with developmental disabilities, as Amy spoke earlier. Targeting the parents of these children and families, we see that at a price point of $2,000 per retail device, there's $34 million market potential too. And finally, in market number 3, of the 4.1 children born annually in the United States, 30% of them are born to mothers over the age of 25 who, when polled, said their number one goal is the education of their children. Targeting these families, we market the simplified version of the Sippc at the mother who wants her son crawling as fast as possible. The Sippc has been shown to help kids crawl so far at a maximum of 1 month prior to the standard crawling time. This market, multiplied by a price point of $250 retail, is $308 million potential. Now Zach's going to explain the business plan that will take us into these markets.
Thank you, Nikki. So we've seen that we have 3 strong markets, and our business plan reflects those three strong markets. We'll be doing a 3-stage rollout. First one, attacking physical therapists. The second one will be targeting the parents of these children with disabilities. And the last one will be trying to offer this product to parents of able-bodied children. So in stage 1, what we did is we analyzed the industry standard. What you can find here is that manufacturers will create this product. They'll then take the product and give that to their distributors, who's essentially a sales force, who will go to the physical therapist, and the physical therapist will obviously use that product. After analyzing the industry and talking with our inventors, we've established that licensing at this point seems like our best option, rather than a startup or an acquisition. So, in a licensing model, what we would do is Sippc would take our intellectual property and go to the manufacturer. They would create this product and then pass it along to our equipment distributor. That equipment distributor would then go to the physical therapist and sell the product, who would pay that distributor the retail price. That distributor would then pay the manufacturer the wholesale price, and then we will be receiving a portion of that wholesale price as a royalty. One thing that we're going to analyze further in this market is there's a potential cash flow from the patient and the insurance company to this physical therapist for incremental use of this specialty item. This is difficult to establish with the insurance company, and our product's a little early on for us to be able to find out exactly if that cash flow will happen. So at this point, what we're going to do is take a conservative approach and assume that won't be there, but we're going to work towards it. Stage 2. We have everything happening in stage 1 that we have in stage 2, except for we have a new emphasis. Now we're going to take this product and get it directly to those parents with children with disabilities. So we have everything going on, but the distributors will now work at getting this straight to the patients, who will then pay the distributor directly through the insurance company themselves, and our existing cash and product flows will increase from there. Stage 3 is a very different market. We're dealing with the educational toy market, so our players are different there. We have had to analyze this market a little bit differently. After analyzing the market, we established that a startup company looked like our best option. So that's what we're going off of at this point in the semester. Sippc's main issue here will be finding a retailer that would like to order our product. So if we can find a retailer that would like to do a bulk order, we can then go to the lowest cost manufacturer and lowest cost distributor to make this simplified version of Sippc to the parents of these able-bodied children. So, for example, let's take Toys R Us and just a regular shipping company or trucking company as our distributor. Sippc will take our intellectual property and tell this manufacturer, please produce it as cheap as possible, and that's how they'll make their money through traditional means. We'll have a shipping company pick it up, and we'll give them the product, who will get it to Toys R Us, who will finally pay Sippc, the startup company. And they'll use their existing business model to create value there. One thing that we're seeing as an option is we might be able to go to a direct consumer model, as seen here. One thing this will obviously do is this will increase our profit, but it also probably decrease our quantity sold. So we're going to keep this as an option throughout the semester, but at this point, it looks like if we go through a retailer, that's our best option. So that explains our business model. Well, let's get to the profit behind it. So let's look at profit per unit. In stage 1, we're marketing the physical therapist. We'll be selling it at a price point of $1,500 a unit at a cost to manufacture at $500. That gives us an additional profit per unit at $32. The next stage, we're looking at revenue of $2,000. This is a higher number because now we can get insurance companies to pay this, and this is what we've established that they're willing to pay for it. Our costs decreased because of economies of scale, and this increased our profit to $66. Our final market is a completely different product, so our pricing points are different. $150 for revenue, and then at a cost of $133 to us. Creates a marginal profit for each additional unit at $17. So this is unit. Let's apply time and quantity to this. So here you see stage 1. It begins in 2014. By the end of 2014, we have $7,500 in net income for Sippc. Starting in 2015, we'll start stage 2. This is a different scale because we're selling at a higher level. So 2015, by the end of that year, we have net income of $50,000. Increasing to the end of the year 2018, we'll be having $200,000 in net income from stage 2 alone. Now moving on to stage 3. Once again, the scale changes and it begins at 2018. As you can see, it skyrockets in 2018. By the end of the year 2018, stage 3 is projected to have $1 million in net income for Sippc as a startup company. Altogether having over $1.2 million in net income for 2018. So this explains the financials behind our business and also our business model. But Sippc isn't quite ready to go to the market. So Evan Fry's here to tell you a little bit about how to get it there.
Thank you, Zach. So as you can see, Sippc has huge potential when we get it to its finished product. However, there's still necessary research and development that needs to go into the product before we can take it to market. Because of the revolutionary nature of this device, Dr. Pitko and Dr. Kologi have received a lot of attention from it and have been able to receive a lot of funding that's accelerated the development of the device. They've received grants from institutions such as the National Institute of Health, the Foundation for Physical Therapy, and the American Physical Therapy Association that's accelerated the product development of this device. And it's really allowed them to target the physical aspects of the device, what the structure of Sippc is, and how it interacts with children in a physical manner in ways that we already explained. What we're looking to do now is to make the jump between the physical and the cognitive realm. By doing that, to show how the Sippc not only teaches children how to crawl, but teaches children with developmental disabilities how to learn and interact with their environment to strengthen those neural pathways through the property of neuroplasticity. In order to do that, we're in need of some additional equipment that we don't already have, and that's in the form of electroencephalography. We'll look to acquire this particular technology in order to measure the cognitive development of infants. We're looking to acquire this technology internally, between someone else at the OU Health Sciences Center or OU. However, we can set up a technical development timeline that shows how funding, if we were to assume that we have to pay for this device on our own, interacts with the product testing and where the product is developing from here. The first benchmark is establishing electroencephalography nets, which are electrodes that attach to the scalp of the infants. Dr. Kolobi is familiar with a fellow researcher here at OU who has access to the EEG amplifier machine. Right now, she would just need to provide the nets to begin a period of clinical assessment, in which she would determine research methods for using EEG on infants with the Sippc. This will allow her to determine, first of all, if EEG is an appropriate method for testing the cognitive development of infants with Sippc, and then to develop good research methods so that she's able to gather good data in future studies. If the results of this look promising, Dr. Kolobi will look to obtain her own EEG system, which costs approximately $70,000. This is necessary because now Dr. Kolobi is going to be taking EEG into the homes of children with cognitive disabilities and using it while the infants are interacting with the device to see how they learn. The rest of this study will be funded by National Institute of Health grant. We're going to be collecting a lot of data in this study as well in attempts to apply for future funding for other studies. We'll be collecting the behavioral data that we're already gathering with the current methods, and we'll also be gathering the cognitive data that we'll be gathering with the EEG. If the data from this phase looks promising, we'll apply for a Small Business Innovation Research Grant, or SBIR, to fund future testing. That's hopefully scheduled to begin towards the end of summer 2012, and there will be additional testing and product development done during that time. This is really important not only because we need to refine the Sippc in order to make it a marketable product, but due to the fact that it is a medical device, we need to be able to convince therapists when we're selling it to them that Sippc truly improves the development of children with developmental disabilities. If we go through this timeline, this will get Sippc a good way onto market and provide reliable data that will help back it up. The total cost, if we obtain the EEG system, is approximately $85,000. So that's a larger picture of where Sippc is heading. Let's see what are the next steps for the CCEW team. We each have our work streams that we're working on, and one of the main ones that we're going to focus on is product development, specifically obtaining EEG nets. Again, we're looking to get these internally so that they come at no cost to us. But assuming we're not able to do that, we'll need to collaborate with Virginia Commonwealth University on sources of funding, potentially securing matching funds or assuming financial risk. We're also going to continue developing our business model. We've determined the cost of producing a single prototype Sippc. What we're now going to do is see how that cost interacts with economies of scale and with our different levels of product in each of the three markets. We're also going to identify potential business partners for our stage 3 rollout. Market assessment is going to continue as we hone in on the markets that we're selling Sippc to, determining a feasible percentage of each of those markets to reach. And finally, our competitive analysis is going to continue as we search for more competitors and determine the market share of each competitor. In all these ways, we hope to accelerate the development of Sippc so that we're able to get this incredibly important device into the lives of children with developmental disabilities in order to improve their quality of life. At this point, we'd now like to open it up for any questions.